Estimating is the make or break skill of any construction business. It will determine whether you win work and keep your business alive, and if you do win work, whether you make money on those projects. Whether you like it or not, and regardless of what anybody says, the construction industry is largely commoditized. 9 times out of 10, clients go for the lowest price. As a contractor, we need to be able to bid competitively, but also to manage our risk so we make sure we make money on our projects. That's why any contracting business needs to be able to estimate both accurately and strategically. So whether you're an employee or a business owner, if you work in the construction industry, you need to be able to estimate. So in this video, we're going to teach you everything you need to know about construction estimating. We're going to teach you what is estimating, when estimating matters, and why estimating is really a game more than a process, when and how to estimate, the components of a construction estimate, the two main estimating methodologies, how to prepare top-down budget estimates and how to prepare detailed bottom-up estimates, then how to properly calculate and apply risk, profit, and overheads. And finally, how to review and submit your estimates to your clients to eliminate risk. Throughout this, we'll do a couple of examples and we'll be using our specialist estimating spreadsheet that I'll attach a link to in the description below. Okay, to start with, what is estimating? So estimating, put simply, is the process of forecasting the cost required to complete a construction project. It's about quantifying the resources we need, materials, labor, equipment, subcontractors, working out how much we need, and then assigning cost to these so we get a total project cost. A simpler way to think about it was we take a set of drawings and specifications and we turn these into a dollar value it would take to construct them. The goal is to accurately calculate the costs to complete a project. So there's 3 broad categories when we need to use estimates. We use them during the feasibility stage of a project. So this would be if we're working for a project developer and we need to work out whether it's feasible to build a project. So we need to determine how much the project will cost before we make a financial investment into it. So you want to build a new apartment complex, you need to work out the total cost of building an apartment complex, and then work out how much you could sell the apartments for. If you can sell the apartments for more than what you can build it for, it would be feasible. But the key bit of information you need to know is how much it costs to build it. We also use it as contractors for bidding and quotes. So this is when we prepare competitive tender submissions for our clients. And finally, we use it in cost control. So this is when we're managing the project costs during delivery and we need to forecast out our cost to complete so we can manage the total expenditure. So who needs estimates and estimators? Well, first one would be project developers when they're preparing feasibility studies, working out whether it's worth building a project. Head contractors or general contractors need them as part of their quoting process, and same subcontractors need them. Finally, the other school or group of companies that need estimators tend to be banks. So banks use them a lot to audit the viability of projects if they're lending to developers and these sorts of things. So what about the different types of estimates? So basically, we can group estimates based on how accurate they are. We've got rough order of magnitude estimates, which would be like plus or minus 30% costs based on minimal design and concept. Got budget estimates, so these would be on schematic or early design drawings, which would give you a plus or minus 20% to the actual price. Got detailed estimates, so these are based on full construction drawings, which will give you plus or minus 10%. And then finally, we've got definitive or tender estimates. This is when we're actually quoting to complete a project. We're putting money on the line, and we need to know exactly how much something will cost. So we've established what estimating is, when it's used, and who needs estimates. Now let's talk about why estimating matters specifically. Why is estimating a skill that can make or break a business? So I want to start by talking about some unfortunate realities of the construction industry. Now, whether you say these are unfortunate or not, depends on your perspective, but the reality is these factors make it harder for contractors to make money. The first one is the construction industry is a relatively commoditized industry. That means clients choose contractors based on price rather than other characteristics. You look at a non-commoditized industry, maybe something like a clothing brand, like you would choose a shirt based on the fact that you like a brand. You're not looking exclusively at the cost. Construction industry, though, is a highly commoditized industry. Clients will choose a contractor based on the price they're submitting. What this does is it drives down profit margins for contractors because they need to sharpen their pencil, lower their cost to give themselves the best chance of winning the work. Second factor is the amount of risk there is in projects. So over 30% of business insolvencies occur in the construction industry. That's going to be a factor of the fact that it's commoditized as well. But also, there's just a huge amount of risk in projects. They're technically complicated. There's a lot of uncertainty. There's a lot of unknowns. You don't know how much it's going to rain for the duration of your project. It might rain a lot, in which case you have a lot of downtime. You spend a lot on delays for inclement weather, which eats into your profit margins. There's a huge amount of uncertainty that impacts our ability to deliver our projects for less than what we forecast them to cost. Next factor is that the construction industry is highly contractual. There's a lot of contracts with huge risk transfers from owners to contractors to subcontractors, and there's strict terms and conditions that surround this. There's penalties if people are late. All these factors impact the ability of a contractor to deliver a project profitably. And finally, which also feeds into how contractual things are, is that scope tends to be complex and technical. It's hard to understand. There's a lot of factors. Every project is different and unique. So the key takeaway for a contracting business would be that the lowest bidder typically wins the project. One bad project can send your business broke because of how much risk there is in these contracts. And finally, this is an important part to draw attention to now. I want to talk about it consistently as we go through the estimating course, but the offer and your estimate isn't just your price. It's also the terms and conditions that surround the price. What this means is that if you say it's going to cost $100,000 for you to deliver this project, an important part of that $100,000 figure is what are your inclusions and exclusions. Now, that is something that people often don't pay attention to, particularly the very detailed estimators who just love crunching numbers. So if you can understand the commercial framework that surrounds your estimate, then you're going to drastically improve your performance as an estimator. If you understand that estimating is as much about the business side of construction as it is about the raw number crunching, you'll do much better. So this leads in to the role of the estimator in a contracting business and why they fundamentally matter, how they help drive profits for a business. The role of an estimator is to secure work at a price we can deliver a project. Now, this is an uphill battle because of all these factors I've spoken about with the commoditized industry, the amount of risk in contracts, but the core goal of an estimator is to secure work at a price that the business can reliably deliver the project. It's much more than just plugging numbers into a spreadsheet. So I want to draw attention to another point, that estimating is an art, not a science. Two estimators can price the same job with the same drawings and come up with completely different prices and both be 100% correct. That's because estimating isn't just the science of doing quantity takeoffs, plugging numbers, taking resources. It's a business decision. It's based on assumptions, productivity rates, programs, procurement strategies, your relationship with your client, your relationship with your subcontractors, what risks you're willing to take, all these factors. There's no correct price for any job, only a price that makes sense for your business, that maximizes your chances of securing profitable work. Estimating is fundamentally a business decision. Your estimate is a function of how much your company wants to win the project, how much risk you're willing to carry, what profit margin you're targeting, how you can spread your overheads, whether you've got 10 projects or you need to allocate all your business overheads to 2 or 3 projects, what terms and conditions you're willing to accept. And accurately pricing the project isn't the goal, it's a step in the process. What I mean by this is accurately doing the quantity takeoffs, preparing the rates, the resources, calculating the total cost is a step in the process, but the goal is to secure the project at a price you can deliver the project. That's the end goal. The process of accurately pricing it is simply a step in that process. Now, I know I keep going over and over the same point, but it's really important. Estimating is the basis of a contract you're going to sign with your client. So you prepare a quote. Associated with this quote are your terms and conditions. You negotiate these terms and conditions. Eventually, you'll sign a contract with your client that has your quoted price in it. You'll sign up to their terms and conditions or whatever terms and conditions you negotiate. And associated this will be the contract price, which you've prepared through your estimate. So when you submit an estimate, you're not just calculating the costs, it's not just an academic exercise, you're preparing to make a contractual commitment. This means any estimate has two core components: the price you prepare and the terms and conditions, the exclusions and inclusions, what scope you're willing to price, what you're excluding. I want to keep stressing this as we go throughout this, but your terms and conditions are just as important as your price. This means the scope of work, the exclusions, and your qualified assumptions. And the more you understand that it's as much about the terms and conditions as it is the price, you'll drastically improve the quality of your estimates and their usefulness in how they help you achieve the overall goal of securing profitable work. So, to summarize the key points, the construction industry makes decisions on price. It's a commoditized industry. If you price too high, you're never going to win work. If you price too low, you'll win work, but you'll lose money on the project, which is a much worse result, and sends construction businesses broke all the time. Estimating is how you find the right balance between the two to win profitable work. Okay, so we've established the role of the estimator and the goal of the estimating process. Let's now talk about construction costs. What are all the different types of construction costs and how do you put them together to prepare a cost estimate? So before we can talk about how to prepare an estimate, you need to understand construction costs. This is the foundation to understanding estimating the different types and where and how we spend money on construction projects. So this diagram I love because it simplifies all the different components of construction costs. I'm going to go through each of these in more detail, but broadly, we can break down all the different costs we incur to deliver a construction project into the following categories. We've got our direct costs, the costs of doing the physical construction work. It consists of labor, materials, plant, and subcontract costs. Then we've got our indirect costs. So these are the costs to supervise, manage, and facilitate the work. So we've got recurring costs, so ongoing costs we incur throughout the duration of the project. And we've got non-recurring costs, so one-off indirect costs. Sum our indirect and direct costs together, we've got our total project costs. And then on top of this, we need to provide our markups. So we've got our margin, our corporate overhead, and our risk and opportunity. Okay, so our direct costs are directly tied to completing the physical works on site. So these are costs we incur to complete what's shown on the drawings and specifications: pouring concrete, excavating, installing electrical cables, procuring plant that we need for the project. These are all direct costs. They're measurable and vary based on the scope of the project. For example, if we need bigger concrete foundations, we'll incur more costs to build these. There's four main types of direct costs. We've got labor, materials, plant and equipment, and subcontract costs. The first type of direct costs are labor costs. So labor costs include wages, allowances, on costs such as super or workers' compensation that are paid to the people completing the physical works on site. These are always going to be a function of the labor rate we have and the labor productivity. So for example, how many meters squared per day of formwork can a formworker install? How many tons of steel can a steel fixer install? These productivity rates will drive the total project cost. Labor costs are going to vary depending on the skill level or type of labor we need. So for example, do we need an electrician or do we need an unskilled laborer? The work type they're doing and the project location. The next bucket of direct costs we've got are our material costs. So these are the raw inputs to delivering the project: the concrete, the reinforcement, the electrical cables. Maybe we have to buy air conditioning units if we're building a building. These are our material costs, and included in these, we need to allow for the actual supply of the materials, the freight to site and delivery, and any wastage impacting this. These prices are often going to be the most volatile and subject to escalation. So for example, if copper prices go up significantly, then the cost of buying electrical cables is going to also increase. Then we've got our plant and equipment costs. So we've got hired or owned equipment needed for construction. So for example, cranes, excavators, concrete pumps, tooling, specialist equipment like that. Within these costs, we need to include the mobilization and demobilization costs. So for example, getting the piece of equipment to and from site, any fuel, servicing, and operating costs, but they will typically be included under labor costs unless we have some sort of wet hire supply agreement. These will need to align with the productivity assumptions we're using for the labor as well. So for example, we have an excavator operator and an excavator. We'll typically combine these rates together to get our built up excavation rate based on the expected productivity per day. But again, I'm going to cover all this when we go through how to actually build up our direct costs. For now, we're just talking about understanding these different types of costs. The final type of costs we've got are our subcontracted costs. So these are quoted prices for packages of work, such as electrical, plumbing, formwork. If we package up a section of work, we get a lump sum price from a subcontractor to complete all the electrical work on our project. Typically, we'll get lump sum pricing, but it's also good practice when we're going through this to understand and validate the cost build-up the subcontractor has given us in case they've made some big mistake or error in how they're doing it. We could get more complex in our contractual relationships with how we engage the subcontractors. We could do certain risk sharing agreements with them, or they could have certain exclusions that we'll need to account for. So subcontractor costs, not as simple as just letting and forgetting. We really need to understand their cost build up and how they price the work and what they're excluding and including. So those are our direct costs, the cost of completing the physical construction works. Let's now talk about our indirect costs. And again, there's two main categories of these. We've got our recurring indirect costs that are going to be driven by the duration of the project, and we've got our non-recurring one-off costs. So our indirect costs are costs required to run the project, but they're not tied to individual work items. So these are big costs like site supervision, site office setup and operation, temporary work. So if we need to put in a temporary access road, site utilities, so getting power, water, gas to site as required, safety compliance, permits and approvals, and they typically form a very large portion of the overall project cost. For maybe around 30% would be a standard industry figure, but it will vary a lot based on the specific type of the project. So recurring costs are ongoing costs incurred throughout the project lifecycle, such as staff salaries. And the key point here is they're driven by the overall duration of the project, which means to accurately calculate them, we need a schedule. The other type are the one-off costs. So these are incurred at a single point in time during the lifecycle of the project, such as mobilizing to site or maybe freight costs. To get our total project cost, we sum our direct costs and our indirect costs. Now, the total project cost is what it would cost us to complete the project based on our assumptions and understanding of the scope. So that's what we would need to spend to deliver the project. Okay, so total project costs is an estimate of the total project costs, and it's missing an important number of elements. The first one is contingency and risk. So these are used to cover unknowns and uncertainties, certain events and conditions. We don't know how much it's going to rain. We don't know exactly what the ground conditions are like. Maybe the design is only a concept design. There's going to be further design revisions, which might cause us to incur additional costs. All these factors will contribute to the amount of uncertainty in the project. The more uncertainty, the more contingency we need to allow. The less uncertainty, the less contingency we need to allow. Ideally, we'd have some sort of risk register with estimated dollar values against all of these. But the other way to do it is simply have a percentage marker on the total project cost. Now, so far, we haven't actually applied any profit margin to our project. So if we submitted the price we'd prepared to the client, we'd be doing the job free. We need to apply some sort of profit margin or markup to the cost to ensure that it's worth doing the project. That's our profit margin. This is going to be a business decision, not a cost. So it's based on the market, what we can get away with. Some projects, if we're contendering them, there's no competition, we could have a much higher margin. There's lots and lots of competition, and we need to have a very competitive price to win. We'd have to have a very low profit margin. Profit margin should reflect the overall risk, so any unknown unknowns, the level of competition, the desired profit, and our corporate overhead. So in competitive markets, this is going to be squeezed down. So that's why it's essential to understand our true costs. So now we understand all the different components of construction costs. We understand direct cost, indirect cost, risk and opportunity, and our markup, margin, and corporate overheads. Now I'm going to start talking about how you actually go about calculating these costs. We're going to start talking about different estimating methods and the two main types of estimating methods you need to understand. So there are two main estimating methods we use. There's the top-down budget estimating approach, and there's the bottom-up first principles approach. They vary based on the level of accuracy and the level of effort. More effort you put in, you'll get a more accurate price. The less effort, the less accurate. Pretty obvious. The top-down approach is a quick, high-level method of estimating based on costs from similar past projects or even past estimates you prepared that you're very confident in. Rather than breaking down the project into every single activity and calculating costs associated with it, we simply apply unit rents or multipliers to the overall project scope. For example, if project A costs $10 million and project B is 50% smaller, we assume that project B will cost $5 million, subject to any adjustments to the scope. So remember back to the types of estimating when we spoke about different types of estimating and the percentage range of accuracy with these. The top-down approach is where we would use when we've got higher variabilities in the accuracy, and getting a finalized price isn't particularly important. So we use it with early feasibility studies, early stage client discussions, rough order of magnitude pricings, when the design isn't finalized, and when you're scoping out whether to pursue a project or not. Basically, use it whenever there's not money on the line and you're not signing a contract to commit to a price. The top-down approach is good when you want fast and easy pricing, when you're just making high-level decision-making. It's also a really good way to verify a bottom-up estimate. So a good way to check a bottom-up estimate is to first prepare the top-down estimate, so you know roughly how much the total project should cost. When you're doing a detailed estimate, the two should align. So the limitations of a top-down estimate is they lack the detail and miss unique scope differences. They rely heavily on historical accuracy and similarity, and they're not suitable for formal bids or signing contracts. Bottom-up estimating, on the other hand, is where instead of taking the estimate from the top down, you build the estimate from the bottom up. So this is where you build the project costs by individually breaking the project scope down into component pieces, and against each piece calculating the cost of doing that scope. The process would be you create a work breakdown structure of the overall project, you price all of the individual activities, you sum the direct costs together, you estimate the indirect costs, and you'll need to prepare a proper project schedule to do this, and then apply profit and overheads. You should use the bottom-up approach when you're preparing detailed tender submissions, you're using detailed cost planning, you're preparing pricing to sign a contract, and basically anytime you need accuracy, traceability, and defensibility. If you're putting money on the line, if you're preparing to sign a contract, you need to do a bottom-up estimate. So the advantage of a bottom-up estimate is you get a high level of accuracy and control. You get transparent and traceable pricing. It allows better analysis and change management, and it supports confidence in your pricing. So limitations of a bottom-up estimate is it's time-consuming and resource-intensive to do it properly. It requires detailed design and scope clarity. You actually need detailed drawings and specifications to prepare it, and it demands more skill and expertise. And I'll add to that final point that it's easier to make mistakes in a bottom-up estimate than there's in a top-down estimate. It's very easy to misscope, use the wrong rates, misquantify things. It's much more error-prone and needs to be checked more thoroughly. The approach I like to use is always to combine the two. So for example, if you're preparing bottom-up estimate, you'd start with the top-down estimate, prepare a rough order of magnitude approach based on the budget estimating approach, and then you could do a detailed bottom-up price to check and validate these two prices. Okay, so far we've covered what estimating is, the different types of construction costs, how and why estimating is used, and the two main estimating approaches. Now let's talk about when to estimate. When during the typical life cycle of a construction project do you need to prepare construction cost estimates? Okay, so if we look at the four main phases of a construction project life cycle, we've got feasibility, tendering, construction, and closeout. During feasibility, we use estimating to help us determine the initial feasibility of a project. Say we're working for a project developer. We then use estimating during the tendering phase to secure new work from clients, to quote jobs. This is the main use of the estimating, what people traditionally think of. We then use estimating a lot during the construction phase of the project. This is when we're pricing variations and change. We also use it as a forecasting and cost control tool. And finally, we use estimating a little bit in the closeout phase to help us do retrospective analysis, look at our actual costs versus our planned costs, basically to review the project and improve our estimating processes going forward. So estimating during the feasibility phase. This is where we use estimating to help us make the business case for a project. Say we're working for a renewable energy project developer. We want to decide whether it's worthwhile to build a solar farm. Part of this equation is working out how much electricity will produce by the solar farm, our revenue, but also part of it is working our anticipated capital cost to build the solar farm, which we use estimating for to calculate the cost of building the project. During the feasibility phase, we typically won't do detailed bottom-up estimates for the sole purpose that we don't have any design drawings or concept documentation. So in the feasibility stage, we tend to use top-down estimating to prepare rough order of magnitude prices. We compare these to benchmark projects, for example, dollar per square meter rate for earthworks or buildings, or we might use dollar per watt for a solar farm. We factor in high-level risks such as site conditions, escalations, inclement weather, and we use this information to provide input for our business case approvals, investor board presentations, and preliminary funding estimates. The feasibility stage is characterized by rough order of magnitude estimates. So design is usually low, incomplete, or conceptual at best. This results in low accuracy estimates, and it's ultimately used as a basis for key decision making. We don't have to be plus or minus 1%. We're not signing a contract to deliver the project for this cost. We're more or less using estimating as a tool to make informed decisions about the feasibility and viability of building a project. Okay. Next, the tendering and procurement phase of a project. The developer has decided to proceed with building the project. They now need a contractor to deliver the project, and then that contractor will eventually need subcontractors. This is typically when we think of estimating being used when we think of estimating. So we use it to submit competitive, accurate offers that win projects at a price we can deliver them for. So estimating in this phase is used by the contractor or the general contractor quoting to the developer, or the subcontractors quoting to the general contractor. Instead of using top-down order of magnitude estimating, because we're getting ready to sign a fixed lump sum contract, we'll use bottom-up estimating based on a detailed scope of works and design drawings. We'll conduct quantity takeoffs, calculate direct and indirect costs, obtain our own subcontractor and supplier pricing, so we have a very accurate understanding how much the project will cost to deliver. We review contract terms, identify risk, apply contingencies, set our profit margins, and as the contractor, we will produce a submission with clarifications, assumptions, value engineering opportunities that ultimately a finalized price that we're willing to sign a contract to deliver the project for. So during the tendering procurement phase, estimating is used as a tool to sign a contract. The value we estimate the project to cost, we will eventually sign a contract to say we can deliver the project for that value. So it's essential that our estimating here is incredibly accurate. This is where contractual commitments are made around scope, inclusions, exclusions, and ultimately price. Poor estimates here lead to losses for contractors, disputes and delivery issues, and strategic pricing decisions need to be made. So whether we want to get more work, so we opt to go in with a lower profit margin and more risk, or whether we've got a big pipeline of work, so we're not particularly keen to win the project unless we can do it at a very healthy profit margin. So while estimates must be grounded in real costs, ultimately here is where a lot of the strategic pricing decisions around the project are made as well. So we sign a contract and we begin completing work. Estimating is also used in the construction phase to help us manage costs, to track performance, keep delivery aligned with the budget, and also importantly to help us prepare and submit and get variations approved. So how is estimating used in this phase of the project? Well, the tender estimate, what we prepare to tender, our price to deliver the work, will eventually become our budget to complete the project. It's used to set our package budgets, our procurement targets, our cash flow forecast. So ultimately, to set up this budget, we need to understand how the estimate was put together. As conditions change during construction, what we also use estimating to re-estimate our costs to complete the project. In addition to using estimating to price variations, so when the client changes the contract work, we'll need to prepare estimates and get them approved. will use estimating through subcontractor negotiations to understand their own price buildups, to negotiate efficiencies and identify value engineering opportunities, to review and approve progress claims, and for forecasting our cost to complete to manage our own budgets. Okay, so while we're not going to be doing the heavy, intensive estimating like we did in the pre-construction, procurement, and negotiation phase, we're still going to be using estimating here a lot as a tool, but more of a tool to understand our own cost build-ups and to prepare and submit variations. So we still need to have a really good, firm understanding of construction estimating to manage this phase of the project properly. Okay, finally, during the closeout phase of the project, we use estimating to compare our actual performance to our estimated performance and refine future estimating accuracy. So we're not necessarily using estimating to improve the performance of the current project we're on. We're going to use estimating to improve the performance of our business processes going forward. How's estimating used in this phase of the project? We're going to conduct cost reconciliation exercises. So looking at our estimated cost versus our actual cost to understand what the difference is. We want to identify the key differences and the root causes. Did we have poor productivity assumptions? Did we have scope creep? Did we actually do additional work that we didn't get paid for? Or did we miss tasks when we were preparing our estimates originally? This feedback is going to help build our historical cost database for our project, our productivity benchmarks, and our risk and pricing assumptions going forward. This whole purpose is to help us improve future tenders, understand how we can price more strategically, but also help us to improve construction going forward. So the key considerations here is a robust closeout review can improve your tendering going forward because you actually better understand how much things cost, where you're making mistakes, where you're missing things, and how to improve this so you can be leaner and sharper with your pricing, but have a better understanding of the project risk. Okay, so now we've spoken about how estimating is used in the different phases of project delivery. Now we're going to do a deep dive into top-down or budget estimating. This is where we prepare our rough order of magnitude prices using comparison data from other projects. Okay, so what's the process for preparing an order of magnitude or a top-down estimate? The first thing is we need to identify a relevant or reference project. Now, this could be multiple projects, this could be one project, or this could even be, if we don't have an exact replica, an accurate estimate we've previously prepared. But that would be the worst form of budget comparison. You're much better going off actual cost data. Next, we want to calculate the relevant unit rate. So what is the key quantity that describes the project? Building a solar farm, it'll be dollar per megawatt. For building a railroad, it'll be dollar per meter. For doing drainage, it'll be dollar per meter. If we're doing an earthworks project, it might be dollar per meter cube. We then want to scale that rate to the quantity of the new project. So we multiply the unit rate by the known quantity for this new project. We adjust for known scope differences. If there's specific changes to the scope, we can use more of a bottom-up approach to adjust the cost by these. Then we finalize our estimate and document our assumptions clearly and how we've prepared this so it's traceable and understandable if anybody wants to review it. Okay, so I'm going to give you a quick example of estimating the cost of a solar farm based on historical data from a 25 megawatt solar farm. So step one, we're using our historical data to get a benchmark rate. So this 25 megawatt solar farm we previously delivered for $30 million. So we divide $30 million by 25 megawatts to give us a unit rate of $1.20 per watt. Step two is then to scale the cost to the new project. So the new project will be 20 megawatts. We apply the same unit rates. So we take $1.20 per watt, multiplied by 20 megawatts gives us a cost of $24 million. Okay, so on this project, we need to adjust for some known scope differences. The key one being that on this project, the client is going to free issue the inverters to us. So we know the inverters cost around 10 cents per watt. So we change our unit rate. We take $1.20 per watt, we adjust for the known scope differences, which is the client free issuing the inverters. We get a new rate of $1.10 per watt, which gives us a new total cost for the project of $22 million. Then we document our key assumptions. So based on similar project scope, scale, and site conditions, we document that we've excluded the inverter supply and we've made no allowance for escalation, design, variation, or site-specific challenges. So anyone who reviews this estimate knows clearly how it was prepared and what key qualifications and assumptions associate the price. As you can see, rough order magnitude pricing is quick and easy, simple and straightforward. The key thing is it relies on historically accurate past project data. If you don't have good cost data on a previous project, it makes doing a rough order of magnitude price almost impossible. Now, in this section, what we're going to move on to talking about is first principles estimating. So taking the opposite approach, rather than just simply copying another project and adjusting it as needed, we're going to build up our estimate from the bottom up. We're going to break the project scope into pieces, price each individual activity in detail. Okay, so what's the process to build a bottom-up estimate? Well, first off, we need to calculate our direct costs. We determine the costs of physical deliverables. We then calculate our indirect costs, the costs of supervising and managing and facilitating works. We then apply our risk and opportunity and markup, so our profit markup and our corporate overheads. We then need to review this, check it for errors, make sure we're confident in it, draft it into a letter of offer, and submit it to our client. Okay, so step one is calculating direct costs, the cost of completing physical construction works. This is 4 steps. So step one is to create a work breakdown structure where we decompose the project scope into deliverables. Step 2 is to form a quantity takeoff where we measure each of the key quantities. Step 3 is to estimate the direct costs. So we've got our activities, our quantities. Then against each of these activities, we calculate the labor, plant, material, and subcontract costs to complete that activity. Step 4 is to summarize these, group the costs to calculate our total direct costs. The next step is to calculate our indirect costs. So the process of calculating the cost to supervise and manage the work. First step, and this is critically important when calculating indirect costs, is we need to identify what they are. So unlike direct costs where we can look at a drawing that shows we have to excavate, we have to pour concrete, we have to install electrical conduits, indirect costs are costs that we will have to identify what they are. What are the costs we need to supervise and manage the work? So step 1 is to identify the applicable indirect costs. We then need to determine what our recurring indirect costs are. So we need to determine how long the project will take us to complete. So we need to calculate a schedule. Then we calculate the cost per unit of time for each of these indirect costs, the recurring indirect costs we need, multiply them by the project duration. And then we need to calculate our non-recurring indirect costs. So these are the costs we calculate in the same way using the same process as our direct costs. We then combine our direct and indirect costs, and we need to add our markup. So our risk and opportunity, an estimate is uncertain. It's a prediction of what we think it's going to cost. So we need to adjust for the uncertain events and conditions that can impact our price. We can either make allowances on a percentage basis, or we can do a full risk and opportunity register and apply costs and probabilities to each items. Once that's done, we need to apply our margin. So this will be our profit margin, what money we want to make for the business from the project, and also our corporate overheads. What non-specific project costs do we need to recover a portion of? You then need to submit our estimate. We've prepared our costs, our markup, we've got our sell price. We need to then review this. We need to check it for errors, omissions, and accuracy. Then we need to draft up a letter of offer where we clearly detailed the scope we've priced, our inclusions, our exclusions, our allowances, and then put in our pricing schedule and submit this to the client. So that's the overall process we use to prepare a bottom-up estimate. Now we're going to dive deeper into each of the stages of this process. And we're going to start by talking about preparing our direct costs, the costs to do physical construction works. So our direct costs are the costs that can be directly traced to specific construction activities such as earthworks, concrete foundations, installing electrical cables and services. Now, the cost of physically doing the project, the cost of physically doing the work, they vary based on the size, complexity, and scope of the project. There's 4 core types of direct costs. We've got our labor costs, our plant and equipment costs, our material costs, and our subcontract costs. So the first type of these costs, and most likely depending on specific type of your business, the labor costs. So the labor costs will be the wages, allowances, and on costs applicable to the people doing the work. So this is the total labor costs will be dependent on your productivity factors. So your task productivity, such as man hours per meter squared and formwork, your overall productivity factor. So what percentage of the time that somebody's at work are they working? So typically this will be something like 85% once you factor in the setting up in the morning, lunch breaks, smoker, these sorts of things, and your daily productivity per crew. So if instead of working as an individual, such as someone doing form work, you might have a daily productivity. So a crew of 3 people can trench 50 meters per day. This will depend on the crew size and composition. So whether you're using form workers, steel fixers, electricians, all of these different types of labor will have different labor rates. Now, most of that is pretty obvious. One key consideration I'd like to draw your attention to is that when people think of labor costs, they think of salary times time, but they miss an important component of this, which is the on cost. So on costs contribute significantly to overall labor costs. So on costs are costs like superannuation, workers' compensation insurance, payroll tax, leave entitlement. So if you're employing someone, you still need to pay them sick leave, annual leave, public holidays, and any site-specific allowances. So within the EBA, they might have travel allowances, site allowances, and tooling allowances. So to calculate labor costs, we take the base hourly rate that someone's paid. Say someone's paid $50 an hour. We then apply our on-costing to this. So this will be typically in the order of 25% to 40% the total cost. So we take someone who makes $50 an hour, we apply a 30% on cost. The cost rates, the cost of them working 1 hour is $65 per hour. We then take the productivity factor. So for example, if we're using a crew can trench 50 meters per day, we then get a labor cost per meter. So if we take 30 hours of work by $65 per hour divided by 50 meters, our labor cost per meter of trenching is $39 per meter. We can then apply this to the total volume of trenching to get a total labor cost for that activity. An important point I'm going to draw your attention to is I use the daily productivity there. If you're using an hourly productivity, you have to adjust by the productive time. What percentage of the time that somebody's at work are they working, as opposed to being on lunch breaks, setting up for the task, and these sorts of things. That's why in my mind, it's easier to use daily productivities when you're doing this. The next bucket of direct costs are our plant and equipment costs. So plant and equipment costs include things like machinery and equipment used for the construction works. These might be cranes, excavators, concrete pumps, scaffolding, tooling, these sorts of things. We have to factor in the actual usage of a plant and equipment, as well as mobilization and demobilization costs, fuel, servicing, and maintenance. With our plant and equipment costs, we can either have hired plants or owned plant. We can own a piece of equipment or we can hire it from someone else. With our hired plant, much easier to calculate because we just charge the daily or hourly rate that we use. This can include the operator, so being wet hire and basic servicing. We need to look at the specific terms and conditions of the hire. For example, for a concrete pump, we might get charged $1,200 a day. With owned plant, we still need to charge plant to the project we're working on, or the business won't recover the cost of owning plant. The costs of owned plant include depreciation, so the original capital investment minus the final sale price spread over the lifetime of the asset, any financing, so interest or lease payment costs we're incurring, servicing and maintenance on the plant, and fuel and consumables. So owned plant rates are a bit more complicated to calculate. Some key considerations with plant costs are utilization rates, so not factoring in idle time for plant. The easiest way to do that is simply use the same productivity and hours for your labor for your plant. So for example, if you're trenching 50 meters per day, that excavator that's being used for the trenching is allocated for the full shift to the trenching activity, even if it's only used half the time. Overestimating plant costs is also a problem when we're over allocating costs to the project and missing mobilization and demobilization costs, which depending on where your project is, are often significant. Okay, the next bucket of costs are our subcontractor costs. So these are costs we pay to external subcontractors and suppliers. This can be on a lump sum basis where we get a full quote to deliver a package of works as per the drawings, or it can be on unit rate costs. For example, we get a rate per linear meter of saw cutting. Typical subcontractors that might be used on a project could be electrical, plumbing, structural steel, roofing. Within the subcontractor's lump sum price, they'll provide all labor, plant, materials in their fixed cost. Okay, so how do we handle subcontractor costs? Well, the first thing is we need to develop a detailed scope of works with clear inclusions and exclusions, and then with verified quantities. It's always better, particularly when you're tendering work and you're not necessarily in a position where you're ready to sign his contract with your subcontractor. It's always better to do your own quantity takeoffs of their work so you understand everything and you ensure that they don't just give you some quick, dirty price and a miskeeping. So perform your own quantity takeoffs of the subcontractor's work. Give them scope of works with clear inclusions and exclusions. What are they providing? What are you providing? And get 3 to 6 quotes for the work. Don't rely on the cheapest price. Take the average price. Perform a detailed gap analysis and make sure you adjust their prices accordingly for any scope they've excluded that you're not aware of. For big important subcontracts, perform a high level first principles check and include the middle price in your estimate, not the cheapest one. The final cost bucket around material costs, so the cost of the raw materials, concrete, steel, reinforcement, electrical cables, plumbing materials, these sorts of things. It's going to depend on our quantities and our unit rates. We need to factor in freight and wastage when we're doing this. The actual process to calculate the material cost is incredibly similar to subcontractor cost. Unless we have some sort of unique business model where we also make our own materials, in 99% of cases, we'll be getting quotes from external suppliers. So we can use the process of getting subcontractor pricing to get our material pricing. Okay, so where are we at? Our direct costs, the cost of completing the physical construction works. For each activity, we need to calculate the labor costs associated with it, the plant and equipment costs, the materials, and the subcontract costs. We sum those together, we get the direct costs for a specific construction activity. As an example, let's do direct cost estimate of building a concrete slab. Now, all we're going to be doing is supplying, installing the concrete, the reinforcement, the formwork. We're not going to worry about excavation or any preparation work such as survey set out. The scope of the project is to construct a 100 meters squared, 150 mil thick concrete slab. So first thing we need to do is we need to get our key quantities by doing our quantity takeoff. So our concrete volume is 100 meters squared by 150 mil thick. We need 15 meters cubed of concrete. Our formwork, which we need around the perimeter of the slab, is 40 linear meters by 0.15 meters deep, and we required 6 meters squared of formwork, and we need the reinforcement. We're going to use a ratio method to calculate this. So we're going to assume there's 100 kilograms per meter cubed of reinforcement. For the 15 meters cubed gives us 1,500 kilograms of reinforcement. So then each of these tasks, we can take the quantity and the rate to calculate the cost. The concrete supply, we need 15 meters cubed of concrete. Our rate is $250 per meters cubed, which gives us $3,750 for the supply. For our reinforcement supply, we need 1,500 kilograms at $1.50 per kilogram, gives us $2,250 for reinforcement supply. For labor, we're assuming to install the formwork, to place the reinforcement, and then to pour the concrete, we need 3 workers for 8 hours to do the entire slab. Our cost rate, so our uncosted rate of the labor, is $60 per hour, which is $1,440 for labor. And we're going to need a concrete pump for 1 day at $1,200 a day. This gives us the total cost of performing the slab of $8,940. Now, these numbers are just made up. They don't mean anything. If I look at those labor numbers, that looks very lean to construct that slab. You get the general point. You go through each of the items. We take the quantity, the rate to get total. We sum those together. We get our total direct costs for constructing the concrete slab. Okay, so let's go back to our estimate components and let's look at where we're up to. So we've done our direct costs. We've worked out for the construction activities we need to deliver the project. We've worked out labor, material, plant, and subcontract costs. We've done this for every activity in our work breakdown structure. We sum all these together, we get our total project direct cost. Now we need to move on to calculating our indirect costs. Let's move on to doing our indirect costs. So indirect costs are the costs of supervising, managing, and facilitating the work. Now remember, our direct costs we can calculate by looking at the drawings, going through all the different drawings and working out everything that needs to be done to complete the project. Indirect costs is a bit more challenging because we need to come up with what are the costs as the contractor we're going to incur to manage the work. It's not going to be shown on any drawings. We're not going to see the crib facilities, the toilets, whether we need a security guard at night. That's why the challenge with indirect costs is making sure we've covered everything. So indirect costs are expenses necessary to run the project that cannot be directly linked to a specific construction activity or work packages. They support the overall project delivery, covering site operations and compliance, but they're not going to be shown on any drawing. They're also known or referred to as preliminary, prelims, or site overhead and running costs. So why are indirect costs so important? First off, they are often underestimated, eating into profit margins when you're delivering the work. They're also driven by the project duration, which is an incredibly hard figure to calculate. So there's a lot of risk in estimating the duration of the project, which will ultimately drive the total indirect costs. Finally, they're hard to quantify. Unlike direct costs where we can look at a drawing to identify them, indirect costs are much more subjective and project dependent. So now we've got to go through our key categories of indirect costs. The first one are our site supervision and management costs. So these are costs like project managers, site engineers, foremen, or even some salary or wages workers that are working to help supervise and manage the work, such as logistics people. We've also got support staff, such as document controllers and safety officers. And these costs are going to be, like with our labor costs, these are going to be a combination of their salaries and any on-costing that applies. Salaries are going to be duration-based. They're going to be recurring costs that are driven by the overall project duration and length. The next category are our site establishment and facilities. This will be the setup and removal of our site compound, purchasing or renting a site office and the fit out and setup, any amenities we need, such as toilets, lunchrooms, first aid stations, or site fencing, signage, and security systems or a security guard at night to prevent people breaking in. Then we've got any temporary works we need to perform to facilitate the works. These would be things like access roads, scaffolding, shoring, formwork not part of the permanent structure. If we had to do like a working platform for a crane, hoardings, traffic management setups. These are all necessary to carry out the work safely and efficiently, but they're not going to be shown in any drawings. So these are temporary works that we have to install and then reinstate at the end of the project. Now, in a lot of situations, you would cover these within the direct costs of the task. For example, if you're doing a concrete structure and you need false work and scaffolding for that, I would recommend including that as it's associated with one specific task in the direct costs. However, if you're erecting a scaffold tower to get access to a roof where 3 or 4 different trades need to work, then that would be covered as a separate indirect cost because it's related to multiple different costs. The line is a little bit gray and blurry, and particularly around temporary works is where it's incredibly easy to miss things. So just make sure you've thought through the actual construction methodology and what temporary works need to be in place to facilitate the works. And we've also got utilities and consumables. So these are things that be like power, water, fuel for generators, consumables like PPE, office supplies, cleaning materials, waste disposal, and environmental compliance. So waste disposal can be quite a significant cost on projects, the logistics of how you manage the bins, how much waste you produce, whether subcontractors are taking away their own waste. All these things need to be considered and covered in your indirect costs. Next, we've got costs like permits, insurances, and compliance. So local council permits, road closures, environmental fees, project-specific insurances like contract works insurance, public liability, bank guarantees, retention, financing costs, and safety compliance. So training costs, audits, documentation, all sorts of costs that we need to comply with laws, regulations, and contract requirements. Now, the next cost, which might be huge if you're working in a remote area of Australia, or might not really be that significant if you're working in the middle of the city, are mobilization and demobilization costs. So this is transportation of equipment and personnel to and from site, including the mobilization of plant, cranes, and heavy machinery, setup costs for subcontractors. All these sorts of things will need to be covered in your preliminary costs. Okay, so broadly speaking, those are all the buckets of indirect costs you'll incur to deliver the project. They will be specific to the project you're working on, where you're working, the country you're working in, all these sorts of things. So how do you calculate these costs? The first step is you need to understand how long your project will take. Most of these costs will be driven by time, which means the longer the project is, the more these costs will accrue. The shorter, the cheaper. The project will drive the staffing, the site facility needs, the utility costs, all of these time-based costs. The next thing you need to do is you need to quantify and identify all the applicable indirect costs. So how many people do you need, for how long, what sort of people? Do you need project managers? Do you need site engineers? What facilities do you need? Do you need an office building? Is the client there for issue that? All these sorts of things you need to work through and identify every single applicable indirect cost. Now, as I said, because these aren't going to be shown on the drawings, this is where you need experienced people who've delivered the exact type of project you're working on to help you identify the specific indirect costs you're going to incur. Then, depending on whether they're a recurring or reoccurring cost, you'll need to apply unit rates for salaries, hire rates, and utilities. For example, a site engineer, they cost $100,000 a year, 12 months, that might be like $8,000 a month. For an office rental, that would be $2,000 a month. And then you multiply these by the durations of the project. Then for your non-recurring indirect costs, you'll simply add these on and calculate them in the same way as you would any direct costs. So these are things like mobilization, permits, one-off compliance fees, insurance premiums based on the contract value. These sorts of things, you add these on, and these are your non-recurring indirect costs. Okay, so when you're talking about indirect costs, time is such an important driver of these costs. If you have a 40-week program as opposed to a 30-week program, you've increased your indirect costs by 33%. So it's really important to understand the duration of the project. Now I'm going to dive more into the realms of contract management, but it's why it's so important to have a program that you've based your price on, and that program forms part of the contract with the client, because for whatever reason, the client delays access to the site, delays free issuing you materials, holds you up in any way, you need some mechanism to cover the additional indirect costs you'll incur by them extending the duration of the project. The other important thing to note is that even if you remove direct costs, whatever the client descopes you, reduces the amount of work you need to do, often your indirect costs will still be incurred. So it's really important to understand what these are and to also show them to your client in a way that makes negotiations much more easier. And they're not necessarily built into the direct cost items into the pricing schedule, but also understand the contract specifics, and because some indirect costs may be reimbursable or they may be covered by your client if they're free issuing you site facilities, office rooms, toilets, first aid, these sorts of things. Okay, going back to our breakdown of the total project costs, where are we up to? Well, we've done our direct costs, we've done our indirect costs, we've calculated our total project costs. We know how much money we will need to spend to deliver the project. Now I need to move on to working out our markups, our risk and opportunity, our profit margin, our corporate overheads. Okay, so the first of these we're going to talk about is risk and opportunity. Our estimate is an estimate. It's based on uncertainty. It's based on uncertain events and conditions. We don't know exactly how much it's going to rain throughout the execution of the project. If it rains a lot, we have a lot of stand down. We have a lot of people sitting in crib sheds that we're still paying while they're delivering the project. We have to do a lot of rework to our earthworks because it's rained so much. Then we're going to incur a lot of additional costs. On the other hand, if it doesn't rain at all, we're going to have saved a lot of money if we've made allowances. Our estimate is based on uncertainty, so we need to understand how to properly manage risk and opportunity. Okay, so put simply, what is risk? So risk is the chance that your project will cost more or take longer than you estimated due to unknown or uncertainties. An opportunity is the opposite. It's the chance of reducing your cost, increasing your margins, getting additional revenue that all add value to your project, again, based on unknown and uncertainty. The process of estimating properly is the process of controlling uncertainty. Every estimate contains assumptions, things we believe to be true but can't fully guarantee. Risk and opportunity management is how we stay realistic and competitive in the face of uncertainty. So now I'm just quickly going to go through the major sources of risk in any typical construction project. Depending on the specifics of your project, some of these might be very applicable, some of them might not be applicable at all, or there might be completely other categories that you need to think about and consider. The first one, which happens on most projects, is unclear or incomplete scope. There might be inadequate design or design details as you're pricing the job on a 30% or even a 15% design. There might be poor client expectations being defined poorly in the scope of works or the contract. And the risk is that you underprice the job because you don't fully understand what's involved in delivering it. Okay, the second type of estimating risk would be material and supplier price increases. So typically around 70% of a project's total costs will be outsourced to subcontractors and suppliers. Of this, there's always a chance that when you're getting quotes when preparing your estimate from suppliers and subcontractors, that by the time you go to then sign a contract and deliver the works, their prices may have increased substantially. So there's always a risk what you're allowing in your tender isn't going to be enough to cover yourself when they're delivering the works. The next source of uncertainty is productivity assumptions. So this would be overestimating how fast crews can work. And then when it comes to actually doing the work, their productivities are less than what you anticipated for, meaning your budgets for labor and plant are going to be insufficient. This might be because you haven't taken into account site access issues, weather, or the complexity of the task. The next one is subcontractor risk. So this tends to be a bit of a problem in more building and commercial construction projects where you have a lot of really small contractors that go out of business and have high insolvency rates. So that means you get prices from a certain subcontractor either before they sign the contract or as they're even delivering the work, they go broke. This leads to incomplete work, you having to take on other subcontractors at high rates. The next one is specific site conditions. Now, this is a bigger challenge in earthworks and any sort of excavation activities where you have unknown ground conditions. You might have a lot of rock, making digging much harder, or you might have a lot of groundwater where you have to procure expensive pumps and dewatering systems. You might even have contaminated soil and have to pay a high cost to dispose of it. So this could be higher excavation, earthworks, disposal, or compliance costs. The next source of risk are unfavorable contract terms. Now, you could say this isn't a risk. This is something you can just manage by reviewing the contract. But in my experience, the contracts construction contractors sign are always very onerous and you can't negotiate away every single onerous term. It really comes down to your relationship with the client and how they enforce the terms of the contract. For example, liquidated damages in a lot of cases will never be enforced by a client. But if you have a really poor relationship with them or an incredibly aggressive client, they may choose to enforce these. They can enforce things like delayed payments, retention clauses, cashing your security. And the risk is you're going to face cash flow issues and penalties that eat into your margin. So now the major sources of opportunity in any typical construction project. The first one is value engineering is opportunity you have when you start to get into the detail of planning your works that you can propose alternative materials and methods that help you reduce your costs. For example, there's a beam that you're going to have to do with expensive propping and temporary works. You could offer to do it as a precast beam. If your client accepts it, you might be able to save a ton of money. So there's always going to be value engineering opportunities if you put in the time and attention to exploring them. The next opportunity is bulk procurement or supplier agreement. So this is where your business will be taking on multiple projects, will be procuring a large volume of a certain good, and across all their projects, they might be able to get discounted rates because they commit to working with one supplier. For example, your project might need 200 meter cubed of concrete, but the business might be procuring 10,000 meters cubed of concrete in the next 6 months. They could package this all up, go to a series of vendors and get the best possible rates because of the big volume of work. So there's always an opportunity to make buying gains with strategies like this. Now, the next opportunity is going to be the opposite of the risk we spoke about before, which is higher productivity. Before we spoke about lower productivities, now we'll talk about higher productivities and efficient execution. This is when we get optimized sequencing, experienced crews, and we can really smash out the work. We might get favorable weather, minimal delays, and basically save a lot on our labor and plant costs. Now, again, Client relationships is a huge opportunity because it's the opposite of the risk I spoke about before with contractual relationships. This is where you build a good relationship with your client. You manage the contract not so much with letters and EOTs, but you're managing it as a personal relationship, and you get repeat business and lower risk of poor negotiations. Now, the final one, which is very contract dependent, some contracts actually have within them an early completion bonus to incentivize contractors to finish early. So if you have something like that and you can deliver the works faster, you'll be able to capitalize on it. Okay, so how do you include risk and opportunity in your estimates? Well, there's a couple of different ways you could do this. The first one is a percentage-based risk allowance. So this is where you add a flat percentage on top of the estimate. You could add 5 to 10%. It's simple, but it's broad, and it's better to use this when you're dealing with unknown unknowns. So these are things you couldn't possibly foresee. So you just want some broad project level contingency that you can draw down on as you complete the works. The second one is performing a proper risk build-up. So a bottom-up analysis where you go through every single risk in the project, you give it both the consequence if it occurs and a likelihood of occurring, and you actually calculate your risk contingency bucket. This is much more detailed, but what it's not going to cover is the unknowns unknown. So you're still going to need some sort of percentage-based risk allowance, but on top of that, you can have a detailed bottom-up analysis. The final thing, which is my favorite strategy, and I think by far the best, is rather than focusing on pricing and risk, you focus on the terms of the contract. So you exclude certain items from scope or qualify your offer or make it clear what your assumptions are based on. So instead of pricing these items and bidding yourself out of a job, you can qualify your offer and focus more on the specific terms and conditions. Okay, so far we've calculated all our costs, we've worked out uncertainty around this cost, and we've got a reasonable figure of what we think we're going to need to spend to deliver the project. Final thing we need to do is we need to mark up our costs to get our sell price. What are we actually going to bill the client for the work? This means we need to cover our profit margin, so the profit generated for the business, and any corporate overheads. Costs will incur running the business that we can't directly allocate to a project. So up until now, estimating has been largely a technical process. We've measured quantities, we've determined unit rates, and we've applied and analyzed risk. But when it comes down to profit and corporate overheads, margin and markup, we move into business strategy. Estimating becomes much less of a science and much more of a game. What is the maximum we can bill our client for and still secure the work? So firstly, corporate overheads, what are they? Well, corporate overheads are costs you incur to run your business that are not allocated to a single project. So these are things like head office rent, admin staff, salaries, accounting, HR, company vehicles, IT systems, insurances, marketing, legal, executive salaries, the cost of bidding more work. These overheads are typically recovered by allocating a percentage across all projects. So for example, if your annual overheads are $2 million a year and you forecast $20 million of revenue, to recover your overhead costs, you need to put a 10% markup on all your revenue. So how do you apply these? You calculate a required overhead recovery rate, which will be a percentage, and then you apply this to your direct and indirect costs. And basically, you need to work out a rate that ensures your business is sustainable. If you can't cover your overheads, you either need to reduce them or you're in the wrong business. Profit is the money you make after you've covered all your costs. So these are your direct project costs, your indirect costs, so your staff salaries, your supervision, and your business overhead. So the business running costs that you can't allocate to a project. What you've got left over after this is your profit margin. Profit margins and the margins you put on it is a pure business decision. Some projects you could have a 50% margin and get away with it. Some you wouldn't be able to get away with a 5% margin. It depends on how much risk you're taking, how much competition you face, how much backlog you already have, and how much you want to secure this project specifically, and your company's financial goals. When setting your profit margin, there's a couple of key questions you should ask. How much do you want to win the work? Are you desperate for the pipeline, for the prospective project? Then you're going to bid with a lower margin. If you're a selective premium contractor, you only want to take on a handful of projects, then you can put in a higher margin. Next question is, how competitive is the market? Is it niche or specialized work? Then you can justify a higher profit margin. If there's huge amounts of competition, there's 20 contractors all tendering for the same project, then it's going to be a lot of pressure on your profit margins. The next question is, what margins do you need to be confident in doing the work? Now, when we're talking about risk and opportunity management, we spoke about unknown unknowns. There is always going to be a chance that your costs exceed your revenue. The way to minimize this is to have a higher margin on your cost. If you have a 50% margin, your estimate could be 50% wrong and you still make money. If you have a 5% margin, then you have very little room to move. So high risk jobs should require higher margins, and low risk repeat clients where you know that exact type of work, you've got a really good cost library, you understand exactly how much this type of project costs, you can justify a much lower margin. Okay, so what are typical profit margins? Again, this is so location, project work, type of work dependent, but big contractors typically sit on a project margin of around 7 to 10%. So these numbers are profit and corporate overheads. Mid-tier contractors would be more like 10 to 15%, and specialty subcontractors would be getting around the 20% mark. Again, so estimating is the scientific approach to calculating cost. Profit and overheads are business decisions. They need to be made by business managers, people who understand the competition, the market, and the business strategy. Great estimators need to understand both. They need to understand the scientific approach to calculating cost, the objective side of estimating. They also need to understand the subjective side, which is the business decisions that surround pricing projects. Okay, so now we've determined our sell price, what we're proposing to charge the client for our work. The final thing we need to do is we need to review our estimate. We need to check it's correct, comprehensive, and we're not going to lose money on this job. Then we need to submit it to our client and come up with a format that we can provide them our quotation. So why is reviewing your estimate so important? Well, for the simple reason that underquoting jobs sends construction businesses broke every single day. Warren Buffett had a famous saying, which was never lose money, and you should 100% apply that in your tendering approach. It's always better to have no work than to lose money on a project. People say you should buy projects. Doesn't make any sense to me. If you structure a business in such a way that you have incredibly low corporate overheads, then there is no pressure to secure work at a price that there's every chance you lose money. To protect against this, you should review your estimate in detail and also structure your offer to make sure the terms and conditions align with what you've priced. That's the key to this step. Not just focusing on the price, but also focusing on the terms. So the first step in this process is to document and qualify. So an estimate is only valid if it reflects what you believe the scope of the job is. Clients may have different expectations. That's why it's important when you're preparing the estimate to document what you're pricing and to qualify. This means clearly articulating in your letter of offer what's included in your price, what's excluded, so the scope you're not pricing, even if they've asked you to price it, and any assumptions. I like to go to the next level of detail where for every line item in the pricing schedule, I write a description of exactly what's included, what drawings I've referenced, and every single assumption and qualification that is relevant to how they would review the price. Now, every estimate you submit, every quotation should be accompanied by a letter of offer or bid clarification sheet. This should include a scope summary, so what's included in your price, your key exclusions, what you have not priced, any assumptions that your price is reliant on, so any assumptions that you don't want to take the risk for, and the terms and conditions of your offer. So payment terms, the validity of your offer, escalation clause, anything you want to cover like this. What will typically happen with a construction tender is the client will send you a draft contract. Now, depending on how serious you are about winning the work, you might, as part of your tender, actually review this contract and come back with a list of departures. What I'm guessing is that if you're tendering a lot of work, you don't really want to waste time doing this until you get to the negotiation table, in which case you can then review the contract and get the terms and conditions of your letter of offer to align with their contract. To me, one of the most overlooked parts of estimating is terms and conditions. Your pricing is based on your understanding of the scope and the terms and conditions of the contract. If the contract changes, if the work you need to do changes, then your price must change. Always align your price to your commercial terms, or you risk pricing for one thing and being forced to deliver something else. So part of reviewing and submitting your offer is getting the terms and the price to align, but the other part is just fact checking and studying your estimate to make sure nothing's missed. So first step in this process would be a detailed review. I apply the 80-20 rule, where 80% of your costs will probably only be in a handful of items. For those big ticket costs, go through them line by line, even do them again to make sure that the numbers you have are spot on. When you're doing this, the key areas to review critically would be any major cost items, subcontractor quotes, productivity assumptions, risk allowances, and your indirect costs. Once you've completed your detailed review, you're confident with what's in the estimate, you think it's correct, you should then do some high-level sanity checks. So you could compare the total cost of the project. For example, if it's an earthworks job, you might do cost per meter squared, or if you're building a solar farm, you might calculate a dollar per watt figure and compare it to previous similar projects or accurate estimates you've created in the past. And you just want to get an idea of, does the total price feel right? Are the buckets of money correct? And if not, to dig deeper and explore why. The next thing I always like to check is review the scope. So not putting the estimate aside, just looking at the work packages you've come up with, the work breakdown structure. Does it cover the entire project scope? Often what happens is people tend to price things correctly. The issue they have is that they miss scope. So it's much easier to check, is all the scope covered, as opposed to, have I priced everything perfectly? And then you can do mathematical checks, but again, this would be error checking the big cost items of your estimate. It's probably going to take too long to go through every line in your cost estimate to check the formulas are correct. For labor and plant costs, a useful check you can do is to check that your costs are aligned with your program. If it's a bigger tender and you are preparing a construction program, and you have a 20-week construction program and that you're planning on having 6 full-time workers on it, you can easily calculate from that your total man hours, which should align with your bottom-up estimates. That's one of the easiest ways to check your labor and plant costs. And the final one, which to me is a non-negotiable, is to get somebody else to go through and check your work. Not so much explain it to them, but to just send them the estimate and get them to review it in as much detail as they want. That's why, this is a comment I probably should have made earlier, but that's why when you're actually preparing your estimate, it's really important to write notes and to set it out in a very clear and repeatable fashion. For example, your direct costs, to have a template where you put all your quantities into it and then have a structured line by line estimate that anyone in your business can pick up and critically assess. Now, once you've checked your estimate, you're happy with your terms and qualification, the final step is to submit it. Your final submission should include your summary of your estimate. So this would be the client's pricing schedule, bill of quantities filled out, your letter of offer detailing your assumptions, your exclusions, and your key terms and conditions, any supporting documentation such as a bill of quantities, a schedule, a program, and also any contact details for clarifications. Okay, awesome work. That's it. That's estimating 101. We took you from understanding the fundamental principles of what is an estimate, what are they used for. Then we went through the process of calculating a detailed bottom-up estimate, calculating your indirect costs, putting on your profit margins, your risk, and then how to finally summarize and submit this to a client. Estimating, as I said in the beginning, is the make or break skill of construction businesses and is fundamental to the success of any business. Now, I said a couple of times in there that one of the key things I think a lot of people overlook in estimating is terms and conditions. So if you are keen to learn more, then check out this video next on construction contract administration, because if you understand contracts, you're going to be a way better estimator.